and welcome to the newest ecosystem project demo. Today we will be talking to Micah about the Interceptor. Have you ever signed a transaction on Ethereum and been somewhat unsure of what the transaction will do? Well, I think today's project will show you a better way of going about that. It's an open source browser extension that provides clarity on some of the hard to navigate Ethereum aspects of token signing and sending transactions to addresses. It integrates with MetaMask, or it can act as a standalone simulation tool. You can test the outcomes of different transactions, test adapt to the eyes of different wallets, simulate your transactions before signing them, and avoid common pitfalls. It does all this while protecting your privacy, and I think it'll be a good tool for people who are looking to have more control over what they're trying to do with transactions. To talk more about it, welcome, Micah.
Thank you very much.
So I think we're just going to do a quick demo today.
Yeah, I have just a few features prepared, and then if you have questions at the end, I'm happy to take them, or if you have specific things you'd like to see demoed, feel free to ask along the way.
Totally, cool.
So let me share my screen here. Okay, I should be able to see Uniswap, right?
Yep.
So we have Interceptor installed, and right off the bat, you'll notice that I'm browsing Uniswap as Vitalik.eth, and I've got 748 ETH. I'm very rich, and this is enabled by one of Interceptor's features, which is if we go into the Interceptor extension up here, you can see that I'm in simulation mode, and when in simulation mode, I can pick any address I want and pretend and use the app as though I'm that address. Now, of course, I can't actually do anything with Vitalik's ETH in the real world, but I can pretend to and utilize this app or any other app as if I was Vitalik, and we can just use it like normal. So we're going to go ahead and select USDT and see if Vitalik happens to have any. Oh, he does. He's got 244 USDT. And so we will verify our transaction. And we'll notice here that Uniswap is saying that we need to allow Uniswap to use your USDT. Anyone who's done any sort of trading is very familiar with this. It's that allow step you have to do for every new application you want to use. And so we're going to go ahead and hit allow here. And this will open up a Interceptor dialog telling us what's happening. And you can see up here it's telling us this is an ERC20 approval, and we're allowing the Uniswap router to spend all of our tether. And one important thing here is we do our best to try to make it clear to the users what it is that we're showing you and what it is that you're doing, and show you very clearly, as clear as we can, what's happening. And so in this case, we're telling you Tether will be able to, Uniswap router will be able to spend all of your Tether. And as a user, you can choose to do this. If you trust Uniswap router with all of your money, you're welcome to. But at least we gave you the information. What we want is people using Ethereum to have informed consent, so to speak, of any interactions they're doing with any application. They should be informed of what they're doing. And if they want to make that choice, we're not going to stop them. We're just going to do our best to alert them. And you'll see later on that we do, in some cases, if we think the thing you're doing is really bad, then we will try to give you kind of an enhanced warning and say, hey, you sure you want to do this because this is a bad idea. In this case, though, this is pretty common, so we're not going to put up any additional roadblocks other than just telling you what's about to happen. In the bottom here, we can hit the simulate ERC20 approval. And what's going to happen is you'll notice that Uniswap now recognizes that we're approved. So up in the top right, it says approve USDT, and it says it's done. It hasn't actually happened. I'm not Vitalik. I do not have his private keys. Nonetheless, Uniswap thinks that I'm Vitalik and I have approved the swap of USDT. So if I go ahead and say swap here, it'll tell me the rate and hit confirm, and I get another Interceptor window telling me what's going to happen. And again, we're all about informed consent and letting people know what they're doing. And so unlike a lot of wallets, we do our best to try to visualize anything we can. And right now we're still early, and so Uniswap's one of the first things that we added this for. Though this swap card, we call these cards, the swap card should work on anything that's doing a basic swap. So Uniswap, SushiSwap, other things that are doing just on-chain swaps where you give one token and you get another token or a coin back. They should all be represented in a similar way. It's not 100% yet, but that's what we're striving towards. And the hope here is that unlike other browser extensions out there that help you with working on Ethereum, the goal is to make it so you really understand what's going on. So we're telling you right here that you're swapping 244.1 USDT, and you'll get 0.1158 ETH. And that's our simulation. This isn't exact because, as you know, due to front running and MEV and all those things, you might get a slightly different rate. But we're telling you, if this transaction was the first transaction in the next block, this is what the rate you would get is. So we can go ahead and hit simulate swap here, and we'll see Uniswap is now saying waiting for confirmation, and Uniswap believes that transaction was confirmed. And so it says, thank you very much. And if we wait just a couple more seconds here for Uniswap to realize, and you'll notice that the balance will refresh in a moment to show 0 USDT and 700 and something more. Yeah, there you go. So we have 0 USDT, and we now have some Ethereum. What's particularly interesting about this is this isn't just Uniswap that sees this. If we go to some other application, we would also see that we now have no USDT. And so I have another instance of a different version of Uniswap here. This is, well, it's the same underlying app. This is a different version, so they're not, these two tabs are not communicating with each other in any way. They are two totally separate apps. Sorry, go ahead and connect this here. And we look at USDT, and we'll see that the balance here is 0 as well. And this is because what we're doing is we are actually keeping track of the series of events that you have taken. And anytime an application tries to query the blockchain, it queries it through Interceptor, and Interceptor says, oh, let's take the current blockchain of all however many years Ethereum's been running, however many millions of blocks, and then add one more block on top of it that includes all the transactions that you've done in this sequence. And so in our case, we did an approval, and then we also did a swap. And so those two transactions are now being tracked. And so any application that we use that we connect to Interceptor will now see those two transactions as though they have happened. They haven't actually happened. They're just in our simulation, just in our browser. But you can now see that this carries over. And so you can do complicated things like maybe go to swap some tokens in Uniswap, and then go over to Compound and do some stuff, and then go over to Curve and do some stuff, and then go over to Aave and do some stuff. And your simulation stack will kind of build up over time as you do more and more things. And we can actually visualize this. If we go look at the extension up here, you'll see that we have these simulation results here. And we see that we're in simulation mode. We're logged in as Vitalik. And in the simulation results, you can see the series of things we did. So first we did an ERC20 approval with this website. And we can see that we approved the Uniswap router to spend all of our tether. And then we can see that we did a swap on this website over here, and we did these things. And again, every website will see these things. And at the very bottom, we show you this is the sum of all the things that you've done, like all these things combined. If there's like many swaps in there or something, you're doing some complicated stuff, we'd show you the outcome, the total outcome of that. So in the end, we lost 244.1 tether. We gained 0.1159 ether, and we have also allowed Uniswap to spend all of our tether. Again, in this case, we've got a very simple setup, very simple transaction. We've just done a couple of things, not very interesting. But one can imagine, doing a dozen different things and be able to see the total outcomes. Like maybe you go borrow some money on one place, and then you lend it somewhere else, and then you leverage that in another place. And then you can come over here and look at this simulation outcome and see the aggregate of what all those transactions did for you in the end. So that's, I'd say, enough about Uniswap. So the reason I have two tabs open for Uniswap here is actually because this one is the Uniswap uncensored. So this is an older version of Uniswap that has all the tracking and censorship stuff stripped out of it. This one is a much newer version of Uniswap, just before they switched to the V4 stuff, which adds a bunch of complexity. So we use this one for demoing. But this is basically the version of Uniswap from, I don't know, a month or two ago, if I remember correctly. And so what we're going to do over on this one is a little bit different. We're going to try, let's see if Vitalik has some DAI. I think he does. Oh, yeah, he's got 1800 DAI, good. So we are going to go ahead and do another swap here, but we'll notice that a slightly different process will be gone through. While we wait, I'm going to verify that on the experimental build of our backend service, which we'll talk about a little bit later. So we want to swap 1818 DAI for some ETH. Go ahead and hit swap here. We'll slow, confirm swap. Okay, so once again, I'm getting an allow here, but you'll notice this is, instead of an ERC20 approval in the top left, this is a DAI permit. And so the newer versions of Uniswap have this, have a new concept where they have a new contract that you do off-chain signatures in order to sign. The problem with off-chain signatures is that if we're just doing the simulation stack we talked about earlier, an off-chain signature doesn't actually happen on-chain, so we can't actually add it to our series of transactions. And so what we've done is we actually are able to, instead of simulating a signature, which we can't do, so we can't actually sign anything. What we're doing instead is we're going to go ahead and simulate this, and when we simulate it, what's actually happening, and by the way, it shows here, for the more advanced users, you can see exactly what's being signed. So this is an ERC 721, I believe, signature. And we tell you as much details as we can extract out of it, what's happening. So we're going to give the signature expire in 30 minutes, which means the spender can spend for 30 days. I'm not an expert at all this stuff, but again, our goal is to make it easy. So this is what we tell the user, the stuff we do understand, and the stuff that's easy. Sorry, I digress. We're going, when we hit simulate DAI permit here, what we're going to do is we're going to return a signature to Uniswap. And so Uniswap now is going to get a signature, which they just did. And that signature is not valid, though. But when Uniswap goes to validate that signature, they go through Interceptor. And so they say, Interceptor, hey, take this signature to Ethereum and check this with the Uniswap, with the contracts to see, is this a valid signature? We intercept that and we say, oh, yes, this is a valid signature. Go ahead and trust us. In this case, this allows us to trick Uniswap into thinking that it has a valid signature, which allows us to move on to the next step. Normally, Uniswap would stop if you don't have a valid signature and say, hey, you need a valid signature before you can swap these things. But instead, you'll notice that it says, go ahead, swap some DAI here. And so we go ahead and hit simulate swap here. And sorry, it looks like Uniswap sent me a couple different transactions. And the second one's going to fail. We'll ignore that for now. And so now it says swap submitted. And so everything, swap success. Uniswap received feedback that it's done. And the second swap, again, I think this is the little issue with Uniswap. I think it submitted 2 transactions. I apologize for that, but it shouldn't matter here. So we can close that. And now you'll notice, once again, our DAI balance is down to 0, and we're up another ETH. So we started this whole thing with, I think, 784.1 ETH. We're now up to 785.12. And if we look at our simulation stack, you'll see we have an ERC20 approval, because same as before. So that was from the first Uniswap thing we did. We swapped USDT for ETH over on Uniswap, uncensored. Then we did the DAI permit, and then we swapped DAI for ETH on Uniswap. This one reverted. This was because, like I said, Uniswap had a little bug there. They submitted 2 transactions. We can go ahead and clear that out and say we don't really want that anymore. Let me gray the screen out for a second. There you go. Okay. So in our little stack that we're building up here, we have converted USDT to ETH. We've converted some DAI to ETH. And if we go down here and look at the simulation outcome, this is again the summary of all the things we've done in this session. And so we've sold 244.1 Ether, or sorry, Tether. We've gained 0.9762 Ether, and we have also lost 1,818 DAI. And so all this is to say that we can allow the user to interact with decentralized applications without needing to take the risk of using the real wallet. So as a real user, I mean, I'm probably, some people, you might want to fool around by being Vitalik just for fun. It's nice to play around with the internet where you have allegedly $3.5 million and you can play with Uniswap, you can play with all these different apps and pretend like you have a lot of money. But I think the real use case here is you actually simulate with your own account. And so you put Interceptor into simulation mode, but you use your real account here. And so you can add any account you want. All you need is an address, and you can add it here and play with an app with that address. And by using your own account in simulation mode, you can go and explore applications that perhaps and see how they work, figure out, play around with them. You can, fiddle with NFTs, you can fiddle with the ERC20 tokens, you can fiddle with whatever. and kind of see the outcome and see how the app works and really get a feel for it and understand what you're doing before you go and actually start signing transactions. And this is a very powerful tool because we really want people to be more informed about what they do and understand what they're doing. And part of that process is just personally exploring. The ability to fiddle around with something and play with something just for fun using play money gives you a lot of power to really understand what you're doing. And so maybe you're just getting into finance and you want to go start doing some leverage stuff. Doing that leverage and playing around with those tools with something like a simulation mode might give you insight that helps you make better decisions in the future when you actually are doing it for real. And so that's why we built the simulation mode, is it allows people to a lot more power to help them understand how applications work. Something else we have built as a kind of separate project. So this is the Interceptor extension that lets you build these simulation stacks. We also have this thing called Bouquet. Bouquet, the purpose of it is to help people who have, primarily the purpose of it is to help people whose accounts have been hacked. When your account is hacked, what usually happens is someone gets your private key or your recovery word or something, and they then set up a bot that just sits on the account, and anytime you send ETH to it, they immediately withdraw the ETH, like a block later. And by doing that, excuse me, by doing this, it makes it so even if the hacker missed some of your assets, which is actually pretty common. So if you've got some obscure NFTs or you're staking in some weird protocol that no one's heard of, the hackers often miss those. Like the things they catch are they get all your ETH almost all the time. They get all of your USDC, they get all of your USDT, they get most of your ERC20 tokens that have any value, but they often miss miscellaneous things. There's also things that the hackers don't want just because it's not worth the gas money to them. So things that they can't sell, they generally don't bother stealing from you because there's no value. They don't want to waste the gas money on stealing something they can't sell. But those things that they can't sell may have sentimental value to you, or they may have value to you but to no one else. Like maybe you've got like a Pope or something that's completely liquid, but having that Pope gives you access to something that only you can get access to. And so you might want to recover those assets from those accounts that the hackers left behind. In that case, what you can do is you can create a simulation stack using Interceptor. And one of the things you can do along the way, and sorry, go ahead and go back to Uniswap here. And so you can see that Vitalik has 785 ETH up in the top right. If you go into Interceptor, you can click this Make Me Rich button. And what that Make Me Rich button does is, it'll take a second to show up here, but what it'll do is it'll give whatever account you're currently browsing as 200,000 ETH. And the way we do this is we basically simulate a transaction from some rando on the internet that has 200,000 ETH. We just dug up an account that's really, really rich. I don't remember whose account it is. I don't think we even know whose account it is. We just found an account that's super rich. We take their 200,000 ETH and transfer it to this account. Again, all in simulation mode. What this allows you to do is you can now interact with applications like Uniswap or ENS or whatever while an attacker has access to your account. And so again, we're only in simulation mode, but it allows you to use the normal applications that you use. You don't have to do any sort of special scripting. You don't have to know how to go and build your own bundles and send them to a searcher or something like that. You just need to go use Uniswap as normal. So I can go in here, as you can see, Uniswap thinks I have 200,700 ETH. And I can literally swap this all right now for USDT. It's a really big slippage. I don't recommend trying to swap 200,000 ETH all at the same time, but we can do this. I mean, how you tell Uniswap to ignore the slippage, but there's a way. But we can do this right now, and if we want. But the point here is that the important point is that we can actually build a transaction stack, just like we've done earlier here with using Vitalik's account. We built this transaction stack. We can do that using ETH that we don't actually have. And so let me do a slightly smaller one here, something that's a little more reasonable. So I'll go ahead and swap some ETH to USDT. And this is, again, using ETH that we just kind of stole from someone else we fake stole in simulation mode from some random person on Ethereum. And we can buy some USDT with that. And we should have that in our simulation stack now. Yep, so we can see we gained 2,110 USDT, and that shows up. And so we built this other tool, Bouquet, that I can now import payload from Interceptor. So this is just an app. It just hosted just out there on GitHub, I believe. we import Intercept from the payload from Interceptor, we can now see that this is that transaction stack that we just had. So this doesn't render quite as nicely. We haven't put nearly as much effort into making this render nice as we've made this render nice. This is a kind of a one-off tool. But the point here is that we've got this funding transaction that comes first, and it's followed by this swap that happens second. And right now it's kind of hard to read. If you click decode transaction from Etherscan, we go to Etherscan and grab the ABI, and so it's a little bit more readable. In the case of Uniswap is not particularly readable at all. We'll perhaps at one point make this a little better, but again, the idea here is you use Interceptor, which does make it clear what's happening. At this point, if you're on a compromised account and you have done this import, and in the perhaps you have the funding transaction, and then you did the swap or whatever, and then you usually want to have a third transaction that sends the money to some safe account that is not, the hacker doesn't control. In that case, you would then put and I'm going to give a clear warning to everybody: do not share your private key ever. If it's not compromised, you should not be giving it to anybody. In this case, we're asking you for your private key for the compromised account. And so, again, I want to be explicitly clear: shouldn't give this to anybody. Even for an account that's compromised, you should generally only give your private key to people that you really trust to help you recover your assets. In this case, this application runs entirely in the browser. There is no backend service that we're sending things to. Everything's done right here in the browser, and so it's a little bit safer than other options. But again, I want to be explicitly clear: you should not be giving your private key away to literally anyone. If you want to trust somebody, I'm going to tell you trust us, but you generally should not trust anybody. And in this case, only put in the already compromised private key. So the private key that a hacker already has, and they're already stealing everything from you. And so you have nothing to lose at this point. So if you were to put the private key in here, and I don't have Vitalik's private key, so I can't do it for this case, but you put the private key in here, and then you would transfer a little bit of gas money, and we'll tell you exactly how much, to that account. Then we can execute these transactions as a bundle. And so what we do is we then sign the transactions, again, all inside the browser, using that private key, and we send it as a bundle to MEV searchers. And the MEV searchers will include it in a block only if all the transactions succeed. And so what this means is that the hacker that normally sits on your account and steals all the gas money that you try to send to it. So even though you just want to get your ENS name out or something, the hacker just is immediately, taking all your gas money. And so what this allows you to do is send a little bit of gas money and then take recover your assets like your ENS name or whatever, all in one block, so the hacker doesn't have an opportunity to steal the gas money. And so at the end, I can't show it here because we don't have a real private key, but there'd be another button down here. Once you get the private key in, you'd simulate it and then hit submit. You wait usually 30, 45 seconds, and then it'll run all the transactions at the same time. And so this is just an example of how we can use these simulation stacks to do interesting things. So in this case, we're using a simulation stack to send a series of transactions all at the same time, with no opportunity for other people, or at least very little opportunity for other people, to slip transactions in between. And so, while this is certainly useful for things like recovery, as we just described here, one could also imagine using that same sort of feature for doing complicated financial transactions, where you really need to be sure that your transactions all happen in a certain order and all back to back with nothing in between. So maybe you're introducing some slippage or something by doing one particular transaction, and then your next transaction removes that slippage opportunity or something along those lines. You can set up a bundle and then use an application like this. And I don't necessarily recommend using this because, again, you'd have to put your private key in here, but one could imagine some other application that does that perhaps you do trust or you wrote or something that you would want to put your private key into, and then it could sign those all as a bundle. We'd also like in the future, hopefully, to make it so wallets can sign transactions without submitting them. And so the reason we ask for your private key here is because we need to sign these transactions, but we don't want to actually submit them. And the problem is all current wallets, if you ask them to sign a transaction, they immediately send it off to the blockchain. And what we want is we want wallets in the future to not send the transactions, instead just return the signed transaction, so we can bundle them up and put them together into a kind of cohesive unit. At the moment, I don't know of any wallets allow that feature, but hopefully in the future that will be allowed, and then we wouldn't need to ask for your private key here. That's what we really want to get rid of this. We do not like asking people's private key. And again, I want to re-emphasize before I move on, please do not give your private keys to anybody, including us. If you're going to give it to somebody, sure, give it to us, but nobody else. And you probably shouldn't give it to us either. Don't trust people on the internet, especially random people with no video who's telling you something on YouTube. Okay, so moving on from that, let's see what we got here. Let's go on to Vitalik.eth here on ENS, and let's say we wanted to extend his name. And so we go ahead and go into extend for 1 year. Sounds good. They're telling us we can save some money if we extend for longer, but no, we're just going to extend for a year. Next, it's giving us verification, asking us, are you sure you want to do this? Hit yes. We'll open our wallet. Which is again going to send it over to Interceptor, which will simulate it. We can see that we're sending some ETH to this address, and we are receiving some ETH from that address. That's a little bit odd. Oh, I think it's because they might give you a refund. Now, what you'll notice here is that unlike the Uniswap card, where Uniswap very clearly told you you're going to do a swap, we don't have as good of a view here. And this is that thing where, so over time, we're building up the set of transactions we can present to you clearly. At the moment, we don't have one for ENS. We do have one for swapping in general. It works for not only Uniswap, but anything else you're doing a simple swap. In this case, we don't have a good card for it, but it is something on our list. We generally try to pick projects to build these visualizations for that we feel are good contributors to the ecosystem. So anything where ENS is very high on our list because of this, because it's not just another staking app or something. We're very interested in building tight integrations and support into applications that actually do useful things for users. And so swapping is something that is useful. That is a tool that people can use, and it's useful and it's very common. ENS is another very useful tool. Nonetheless, what we can do is we can go and look at the token events. Now you'll notice here that these aren't very readable. This is about as readable as MetaMask gives you. The advantage here, though, is if we click this little button right here, we can then fetch from Etherscan. What this is going to do is going to go to Etherscan and get the ABI. And you'll notice that we could do this automatically, but something that we care a lot about is user privacy. And part of user privacy is not telling the world what you're doing at any given point in time. If we were to go automatically fetch this from Etherscan, again, which we could automatically fill this all stuff in, but we choose not to very intentionally because we want to make sure that anytime the user is sending any data to some third party, we make it very clear what is being sent and why, and we give the user agency to choose to send that or not. And so here we're giving the user the opportunity to say, hey, you want to fetch the details from Etherscan so we can make this view better for you? Go ahead and click this button. As a user, you can then decide, do I want Etherscan knowing that I'm interacting with this contract or suspecting that I'm interacting with this contract? If not, you can leave this out. Alternatively, you can go over to Etherscan and copy this manually. So instead of doing it through your browser, maybe you go to another computer, or you use a VPN, or you do some weird air gap thing. Whatever OPSEC you want to use to get this ABI. However you get it doesn't matter as long as it shows up here. Maybe you have your own copy of the ABI that you got a long time ago. And so this again gives the user the control over their privacy. We don't want to stop users from going and getting this data from Etherscan. Like, it's up to you if you want to. We just don't want to do it automatically. Most applications will happily go out and tell, every time you use the app or you touch something or you click a button, they tell 17 different services that you just click that button. And that's not always something that you want. You don't necessarily want people fingerprinting you based on what buttons you click and what you're doing, what you're interacting with. We don't want someone coming back and saying, oh, we noticed that you looked at the Torn token because we have that information because we sent a subpoena to Etherscan to tell us everything that you did. And one of the things you did was you looked up the Torn token. We're going to use that against you in court. Or whatever the ridiculous situation that you're in, we want to be very careful to give you agency over what information you give out and to who. This is informed consent, again. So we're informing you. We're going to go, if you click this button, we're going to go to Etherscan. We're going to get this ABI data for you, and it'll help. It'll make this screen better, as we'll see. Go ahead and modify here. But it's your choice to do that or not. And then while we wait for that to fill in, it takes just a second here, we'll go ahead and do the same thing to this one. And I happen to know this contract is the ens.eth registrar controller. And so I'm going to go ahead and fetch from Etherscan on that one as well. And we'll wait a few seconds. Play some Jeopardy music. There we go. And so now, again, this isn't ideal. This isn't a perfect rendering. Like we really want those cards to very clearly tell the user what they're doing. In this case, though, we're trying to give like the next best thing for the situations where we have not yet taken the time to go and do tight integration with that app. And so we can see that we're calling this name renewal function. We're giving some ID. Don't know what that is. We're giving an expiration date. You know, as a user, I probably don't know what that is either. But what I can see is that we are doing name renewals with the ENS name service and the ens.eth registrar controller, which again, I already happen to know what this is. You can get this information off Etherscan, and we'll be adding a feature in the future, so we will automatically populate this for you if you so choose. And again, this will be opt-in. And so now that we have that, we can see a little more detail of what we're doing, and this is compared to this. So if you in most wallets, what you'd see is this big string of hex, and that's it. Maybe you'd see this bit up here of who you're communicating with. And this big string of hex. What we're trying to make is we give you a little more information about what's actually happening. And so we can go ahead and hit simulate here. And just like before, even though I am not Vitalik, ENS thinks I am. And so ENS is, believes that I sent the transaction and it's telling me that it's processing. Something that's good to know is that Interceptor works great for applications that are built in a decentralized way. When I say decentralized here, what I mean is applications that when they interact with the blockchain, they interact with the blockchain through your wallet, and they don't have some back channel they're interacting with. The nice thing about applications like that is even if the people who built the application go away, the application will still work. So as an example of that, this Uniswap interface that I'm using over here, this Uniswap uncensored, this will work even if the entire Uniswap team disappears, all their servers go offline. We're in some post-apocalyptic world, and all we've got left is the internet and Ethereum and your web browser. This page will still work. And so that's the sign of a good decentralized application, is one that will work without any third-party servers. Not all servers on Ethereum, or not all applications on Ethereum are like this. Many applications, what they do is they'll interact with your wallet to a limited extent. Like they'll get the address from your wallet, for example. So it's like, oh, what's your address? And you tell it your address is this. And they say, okay, you're Vitalik. But then they go and they ask their servers, how much ETH does Vitalik have? Or, how much USDT does Vitalik have? This has two impacts on Interceptor. One is that the applications like that generally don't work super well with Interceptor. And we'll go over one in a little bit and kind of show you what that looks like. Two, though, is Interceptor helps you identify these applications. If the application does not work with Interceptor in simulation mode, it means you are not interacting with a truly censorship-resistant application. You are interacting with some sort of perhaps middle ground, kind of decentralized application, kind of centralized thing in some cases. In many cases, that's the case. But if you can't do everything in simulation mode or things aren't working properly, then you should maybe ask yourself, do I want to be interacting with this app? They could take it away from me at some point. This app could decide to turn their servers off, or, worse, they could censor me specifically. And we have seen this in the past. Uniswap, for example, the reason I originally built this Uniswap uncensored was because Uniswap did actually stop blocking people in certain parts of the world. So if you're, living in a certain part of the world, you now can't use Uniswap because the Uniswap servers decided that you're not allowed. And so you really want to be using applications that don't have the power to turn themselves off just for you or for a certain demographic of people, like everybody in Venezuela or everybody in Iran or wherever it is you're living. You don't want to be in that situation. And so by using an Interceptor, it can help you identify which applications are actually decentralized and which ones are not. And so the applications we've been using so far, I believe, are mostly decentralized. But let's go on to one that's kind of that half and half that I talked about. So I've gone ahead here and I have loaded up Compound. And so this is just Compound Finance. And one of the things that you will notice is over here in Uniswap, I have 2,360 USDT, right? And the reason for that is because I, bought a bunch of Tether. If I go over to Compound, and I believe Compound has USDT in here somewhere. Sorry, I don't use Compound very often. Yeah, we can cut this out. Let me go buy some Chainlink. So before using Compound here, I'm going to go over and buy some Link. So I'm going to go over to Uniswap and buy some Link. Do Chainlink token, and we'll buy 1,000 ETH worth of Link tokens. I'm sure we'll get a great deal on that. Okay, go ahead and confirm swap. Interceptor is confirming that swap, and we see I'm trading 1,000 ETH for 144,000 Link tokens. Hopefully that's a good deal. Don't know much about Link, but there it is. Okay, go back to Compound, or rather, let's actually wait here. So if we wait for, we now see in Uniswap, I have 144,200 Link. And if we go over to that other version of Uniswap that I've got running, which is, again, this is a different application, they're not communicating with each other in any way, we see that here it also sees that I have 144,000 Link. If we go over to Compound, though, Compound still thinks I have 0 Link. It doesn't see that I have all that Link. And so I can't supply it, right? It still thinks I have 1. And this is an example of a kind of decentralized app. It does get my address from here. So this 0xD8DA, right? That is the address that it sees me as having. So it recognizes my address, but it's not using the wallet to get my balance. It's using its backend servers. What this means is that if its backend servers go down, or if it decides to censor you for any reason, you will not be able to use this application. This application will not work for you. Like, this page won't work. And we're able to see that by just seeing that it doesn't notice that we have all that Link now. Like, we should have 100,000 Link in here, 140,000, whatever, 144,000 Link should be showing up, but it's not. There are some things we can do with this application that don't require it seeing changes on chain. So in this case, Vitalik's account does happen to have some ETH, and so we could go over here and supply, 100 ETH. Add an action, submit transaction, spin for a little bit here, and then we can see we're giving allowing Compound to spend all of our ETH. Sure. Approval pending. And so again, this is that same sort of problem where we need to approve, just like we did over in Uniswap. We did the approval first, and we do the swap second. But Compound will get stuck on the approval because it's not asking the wallet. It's not going through the wallet to access Ethereum. It's going through their own centralized servers to access Ethereum. And by going through their own centralized servers to access Ethereum, they don't see that transaction show up because that transaction is only in our browser. Right? We have it in our browser here. You can see it down here. Compound Finance, allow it to spend all of our Compound, it looks like, Compound USDC. But Compound app doesn't see it, and it never will. So this will sit here and spin forever. In this case, we're just going to go ahead and clear it and disconnect the wallet because we're angry. So again, two sides of that coin. Interceptor both can be frustrating at times because you can't see you can't work with all the applications, but it gives you insight into which applications are actually doing what they're supposed to do. So another tool that we built here is Lunaria. So all Lunaria is, this is a tiny little app. All it does is lets you send assets from one account to another. This is just send ETH or send tokens. The reason we built it is because most apps that allow you to send ETH or tokens either aren't decentralized, meaning they have some backend server they use, or they're just built into the wallets themselves. And anything that's built into the wallet, Interceptor can't see. Like, we're blind to what happens in the wallet because we sit between the wallet and, sorry about that. We sit between the wallet and the application. And so if you're using MetaMask, for example, and you just send some tokens directly in MetaMask, we don't have any insight into that. We can't do any simulations. MetaMask won't see our simulations, etc. And so we built this tiny little tool. All it is a simple wallet. It lets you send one asset to someone else. And so we have some assets just built in by default. We keep the list short intentionally. These are just very, very well-known common things. And this is a purely decentralized app. We don't make any external calls whatsoever other than through your wallet. And in fact, the app doesn't even work if you don't have a wallet connected at all. And so in this case, I recently bought some Link, right? And so if we go over here and look at Link, we can see, oh, I've got that 144,000 Link. And so if we go over to Interceptor and let's see, where is it? Sorry. Take a second here. Oh, I lost my stack when I refreshed, I think. Okay, I'm just going to buy some Link. Reset. So over in Lunaria, we just want to transfer some assets. So let's go over here and let's buy 10 ETH worth of Link. I cleared my earlier swaps. We're going to swap it again. Go ahead and confirm that. Simulating to do 10 ETH for 1.4 something K Link. Confirm. There we go. And if I go look in Interceptor, I should see a simulation stack now, and it's showing me Link. In this case, I want to copy the Link address. So I can go in here and just copy its address. And I go over into Lunaria. Oops, I'm going to add the Link token. Retrieving token information, save and use. And then I'm going to, let's see, who do I want to send it to? Let's just say I want to send it over to, I don't know, Uniswap. So I have the Uniswap router address, and this is just me getting an address from somewhere. So copy that address and just paste it there, and I'm going to send the max. We go ahead and start this transfer. This is just a simple example of this. We'll notice that we got a warning here, and it won't let us hit the simulate. It's telling us we're sending 1.46K Link to this address, but it's noticing that we're sending tokens directly to a contract. Sometimes this is reasonable and you want to do this. For example, maybe there's you have a Gnosis safe or something. And in those cases that we were aware of, we do our best to not show this warning. But in the cases that we're not familiar with, where we just say, hey, we're not just sending tokens to a contract, you usually don't want to do that, because usually if you're sending tokens to a contract, like if you sent tokens to the Uniswap contract, they would get stuck there. You'd lose them. And so we give you this warning that's let you know, hey, you're attempting to send tokens directly to a contract. As you mentioned earlier, we don't want to prevent you from doing anything you want to do. We just want to give you informed consent. And so we're letting you know there's something weird is going on that we're suspicious about. And so we force you to check this box to say, yes, I'm sure I want to do this. And we try to be very careful about this box. We don't want to show it so many times that people just start checking it without thinking. We want it to be a real warning. But at the same time, we also don't want to be underprotective and kind of never give people warnings about doing something stupid. And so in this case, we gave a warning saying you're about to do something that we think is a bad idea. But if you really want to, you can continue. And I can go ahead and hit simulate here, and it would work. It would go through. And I would now be out of my Link, and I would never get them back because I just sent them to Uniswap contract. So we're going to clear that out of our simulation. So I get my Link back. So another thing you may want to, a mistake people commonly make is they will add some new token, right? And like in a tool like this or any other tool, you'll add a new token, you'll copy the token address, and you paste it in right here, right? And so you get the token address, you paste it, you say use, and so now we're sending there. Then you go and copy the address of the person you want to send it to, and you paste it here. But for whatever reason, you accidentally copied the wrong address, or you didn't copy the address at all. Like you accidentally hit Control V instead of Control C on your keyboard, and so you still had your token address in your clipboard in your copy buffer. And so what happens? You paste it here, not realizing it, and you go ahead and send all this stuff. And we do two things. One, Lunaria will try to warn you, say, hey, you're sending wrapped ether to the wrapped ether contract. You probably don't want to do this. This will almost certainly result in loss of funds. Are you sure? And you can say, sure, I want to go ahead and do that. More importantly than Lunaria, though, because not everybody's using Lunaria, Interceptor will also detect this. And so we detect that, hey, you're doing this thing that is a common mistake. And it is very unfortunate how common this mistake is. There have been, I don't know how many hundreds of thousands or millions of dollars have been lost to this exact mistake, where people just copy a token address and they send the tokens to that address. Almost every single token on Ethereum that doesn't have built-in protection against this has its own tokens in the token contract because someone sent it to the token contract. And so in this case, Interceptor is stopping you and it's giving you a warning saying you're attempting to send token to itself. This is a transaction that doesn't make sense. You would almost never want to do this. We'll let you do it. And you'll also notice here we actually give you two errors. One, you're sending the token to yourself, and two, you're also sending directly to the contracts. Both those things are common mistakes people make. We'll let you do it. You're going to lose your money here. If I hit simulate with, I'm going to lose my simulated, my fake money. If you do this in reality, we'd also give you the same sort of warnings here. We try, with Interceptor, we try to notice the most common scams, the most common mistakes that people make, and we give them warnings. Another very common one is you're asked to do an ERC20 approval of your USDC or whatever to an externally owned account. This means not a contract. There is almost no reason you would want to approve some other account to be able to spend all of your money. There is a few situations. There are some exchanges who do this, where you're actually sending the money to an exchange and the exchange is receiving it with an EOA. But for the most part, it's very uncommon. So that's another one we'll give you an error for. And so with Interceptor, we try to keep up to date on what the latest mistakes people are making, the common ones, and what the common scams out there are, and try to give you warnings when we notice you're about to do something that we think is probably a bad idea. Again, we'll never stop you from doing it. We'll always let you do it. But we want to make sure that you're informed about what you're doing. So I'm going to go ahead and do the stupid thing there. And that's okay, because we're in simulation mode. And this is, again, nice thing about simulation mode is you can fool around. You don't have to worry about messing up. Like in this particular browser, I only have Interceptor installed, and I'm able to just freely browse any decentralized application and do whatever I want. And I don't need to worry about screwing up with my own money. And I can do this, again, with my own account and get a feel for how things work, play around, and then at the end, maybe I go back through and do these things for real. The other feature, which I'm not going to demo here today, is that Interceptor, in this use case, in simulation mode, is your wallet. It functions as your wallet. And it's a fake wallet, but it functions as the wallet unless you interact with everything. In signing mode, which I'm not going to demo because I don't have an actual real wallet installed, if I had MetaMask installed in the same browser, in signing mode, what happens, Interceptor sits between the application and MetaMask. And so I get all those same protection features. I don't get the simulation features, but I do get the protection features, like noticing that you're about to send money to a contract or access to a contract, or noticing you're about to send to the token itself, or giving you those detailed information about what the app is asking you to do. And that detailed information about what the app's asking you to do is really useful for protecting yourself against scams. So there are scam websites that will tell you, they'll look just like a regular website, like they'll look exactly like the real ENS website. And they will, ask you to do something that seems legitimate and normal. Or maybe it looks like Uniswap, and it'll say, hey, you can swap between any tokens. And it looks exactly like Uniswap, and it functions like Uniswap. But then when you click the swap button, it doesn't actually swap between the tokens. It just sends the money to their own accounts. And so Interceptor will help you see what it is that the app is actually asking you to do before you do it, and before it makes it to MetaMask. If you click the sign button when you're in signing mode, in the Interceptor pop-up, so the Interceptor pop-up will happen first, then it'll give you all the details, give you warnings if there are any, and then when you hit sign, it actually then sends it over to MetaMask to get the final sign. So then you'll get a second pop-up from MetaMask. It looks just like normal MetaMask pop-up, where you can finally sign the transaction and send it off. And the reason for this is twofold. One, the reason we built Interceptor isn't because we want to run a wallet. I really have no interest in managing private keys. It's a very hard thing to do well and securely. And so we don't want to build a bunch of wallet features. Two is we want anyone who's using any wallet that they choose to be able to get the protections provided by Interceptor without needing to switch wallets. We don't want people to have to trust us explicitly. We want to provide value to people, but they can still use MetaMask or use Coinbase Wallet or use Brave Wallet or whatever it is that you're comfortable with. You can keep using that browser wallet and use Interceptor in the middle. And so you can get the protection without needing to have yet another person who has your private keys, which would be us in this case. So I think that's most of the core features of Interceptor. Again, we didn't show signing mode, but it's basically exactly the same thing with all the protection features without the simulation features, and it allows you to use your real wallet and do real transactions. We showed you that you can do simulations. We showed you that you can pretend to be someone else. We showed you that we have this other product, Bouquet, that allows you to do asset recovery. I'm sorry, I'm not in signing mode, simulation mode anymore. So we had Bouquet, which lets you do asset recovery. We showed you the protections we offer. Um, Overall, our goals with Interceptor is to help protect Ethereum users while they're using Ethereum. Like while you're browsing the internet and you've got your Ethereum wallet there, we want you to be protected and feel comfortable to use dApps without needing to wonder, am I about to be scammed? We see a lot of people getting scammed. And because of this Bouquet feature, in fact, most of our users so far are people who have been scammed. And they come to us looking for help rescuing. And we help them rescue, and they're very, very appreciative, and they're very thankful. But we'd much rather prevent them from being scammed in the first place. And so by using Interceptor to help them do the recovery, they're also protecting themselves from the future, because now they have the Interceptor installed. And so hopefully they leave it installed. And if they do, they'll hopefully be less likely to get scammed again in the future. And over time, we will continue to add features that protect from scamming. One thing we've been considering doing is, since we're injecting into every page anyways, we can look for any page that asks you to paste in your private key or your secret words. And if we detect something that looks like a private key or looks like secret words, then we just immediately clear it out or something, or at least give you some sort of alert or warning or something that says, hey, you really shouldn't be pasting that thing you just pasted into this web page. That we don't have that yet, but it's on our list. We have many other protections we want to add to our list. We have many cards we want to add to the list. And we have a lot of work cut out for ourselves, all in the name of protecting users of Ethereum. And again, privacy is one of our top things. Unlike most services, we do not do any sort of analytics, even though they would help us get a better insight into what users are doing. We feel that user privacy is more important than our own analytics and being able to improve our software. We'd rather you be private. At some point in the future, if we do add any sort of analytics data gathering, it would be opt-in, not opt-out. And so you would, as a user, would have to say, yes, I actively want to ship data to you guys so you can help make the product better, rather than the opposite. Most applications, as people know, force you in, and then you have to go dig through some setting buried deep somewhere to opt out. And then you have, everybody's seen the GDPR, GRP, whatever it is, cookie warnings, where you can opt out, but not of everything. You can only opt out of some of it. We wanted to make sure that you can opt out of everything. Like there's nothing that you would send to us. There is one caveat there. Right now, Interceptor is using, we have servers for Ethereum JSON RPC, and you can see them here in the list. And if you go into settings, you can see them. The reason we have this is because at the moment we're using some bleeding edge technology which is ETH multi-call. And we just actually talked about this yesterday at the Ethereum All Core Dev call. We're trying to get this standardized. So we're working with the Geth and Nethermind teams to get this standardized. Once it's standardized, then it will go into hopefully eventually go into all major clients. And once it's in all major clients, then third parties and anyone running an Ethereum node will have access to it. Once that is the case, then we will make it so users can add their own RPC here. And that is very important to us. We actually don't like running servers. It's kind of a headache, and we'd rather not. And so we're really pushing hard to get this one piece of information. So we do send your requests to our servers. We don't log anything. We do our best. There are some intermediate people who may see it, like we use Cloudflare, for example, for edge US protection, and so they may see the information. So we want users to be aware of that right now. It is very high on our priority list, though, to get rid of that and make it so users can enter their own RPC server. Once we have that, then there's literally nothing that we will send to anyone other than the RPC server you choose. And if you click those buttons, like showed with the import from Etherscan, where you're intentionally opting in to send some data to a third party. We really care greatly about this, and it's one of the things that we hope will eventually set us apart from many of the other tools in the space, is that, unlike the other people who just, they talk a big game about how they care about privacy and whatnot, but then they proceed to enable analytics by default, or, have default RPC servers or make it so you can't change the RPC servers and things like this. We really try to go above and beyond and not do those things. And like I said, right now we have not achieved that, but it's only because this feature is not standardized, and we're actively working with the Ethereum development teams to get it standardized specifically so we can get rid of this one last hole that we have. So with that, do you have any questions?
So yeah, that was a super cool overview of a lot of the capabilities that the Interceptor has. And I think a lot of people will be very interested in trying it out, using it in their regular workflow, as it just natively provides a lot of security features. One of my first questions was just, what is the availability like? What browsers is it available on? What networks does it work with? And where else can you download it?
Yeah, so it currently is available on Firefox and Chrome stores, and which means it's also available for Brave. It only works on desktop right now. You might be able to install it on a mobile browser, but I have zero confidence it would actually work properly, so I don't recommend it. As far as networks it supports, we currently support Ethereum mainnet, Ethereum Goerli, and Sepolia. And the reason we don't support more, the primary reason is because, like I said, we're using this special multi-call feature that we're currently working on standardizing, working with the client team on standardizing. Once that's standardized, most of these other alt chains or layer 2s and whatnot, they tend to just copy either Geth or Nethermind or Base or something like that. So once the multi-call feature is in mainline Geth, mainline Nethermind, mainline Besu, mainline Aragon, then we should see that same feature start to show up in all these other blockchains, all these other layer 2s, et cetera, that are very similar to Ethereum. Because like I said, they just use the same clients, they kind of copy the code over. And so that's one of the big reasons we want to standardize this, is so that we can become more available in the future on other blockchains, other layer 2 solutions, et cetera. Right now, we're not available on any of them, but I'm hoping that within the next, if things go really well with this ETH multi-call standardization, I'm hoping that early next year we'll start to see some of the first chains other than Ethereum receive this feature, because it'll hopefully be standardized and live on Ethereum mainnet by then, and which means other chains will start to add it shortly thereafter. And so I'm cautiously optimistic, like Q1 next year, we'll start to see additional chains be added. And once these chains add multi-call, there's really nothing we need to do that's special for these other chains for the most part. We just need them to have this one feature that currently isn't even available officially on Ethereum yet, but will hopefully by the end of the year be. And then so early next year, hopefully we'll start to see other chains. And then once that starts to happen, I'm optimistic that it will kind of spread pretty quickly. I think this multi-call feature that we're trying to standardize is really beneficial, not just for us, but for everybody. Like, it's just a great feature all around. And so, yeah, hopefully more chains early next year.
Yeah, super cool. You talked a lot about the standardization work that you're doing. A lot of the features of the Interceptor seem like something that many different wallets would be interested in implementing a piece of, or using in a dApp UI or something. So could you talk a little bit about your work with standardizing some of these features, like across the Ethereum ecosystem?
Sure. So, a lot of the protection features we're doing, that's kind of just manual work someone needs to go through and do. It's kind of like that, which I spent most of the time talking about. That's the core of that is basically this ETH multi-call that we're trying to standardize. And so we initially, I wrote a plugin a very long time ago for Nethermind that we used for a very long time. And I think we still have a server up that uses it. And then we saw that someone else wanted a similar feature, and they posted a proposal for standardization of it. We then worked with them and the Nethermind team and the Geth team to try to get this into the clients. And we now have working builds in both Nethermind and Geth. We're basically going through the final steps of debugging and soliciting feedback on that. But hopefully, once this multi-call is out, our hope is that other wallets adopt it, and other wallets allow users to start doing the simulation stuff. The simulation stuff is very powerful for giving users kind of more informed consent about what they're doing. And so while the cards and the rendering and the presentation is something that's very manual labor of love on our end, the multi-call thing, once standardized, our hope is that every wallet adopts it. Like we're trying to make the Ethereum ecosystem better is our primary goal with this whole project. And that doesn't mean everybody uses our thing. That means if we build a good thing and it's so great that every other wallet wants to integrate with it or use that same feature, that's great. And that's why one of the reasons, along with the privacy reason, but along with along with the privacy reason for wanting to get away from running on servers, by standardizing multi-call, it does enable other wallets to have the same set of features and have these similar features. And by having these features, hopefully users will become more protected and more cautious and better able to just play around on Ethereum. And that's really what we want in the end.
Yeah, that's incredibly cool. And I know that you guys have a public GitHub repo where you do all of your development. So that also gives some credence to anyone can kind of take these features once multi-call is approved and start integrating the pieces that they find useful.
Yeah, and in fact, we don't only have our source code all out there on GitHub. We also are licensing it under the unlicensed. The unlicensed is basically a license that says we want anyone to be able to use this for any reason, whatever. We don't care. Do whatever you want with it. It's essentially a license that tries to fill the void of needing a license while being as absolutely permissive as possible. And a lot of people consider like MIT and Apache to be permissive licenses, but they still require attribution at least. You're required by law, for something that's MIT license, to give credit to the people who wrote the original code. We don't even require that. With unlicensed, if you just want to copy your code and steal it and claim it's yours, go for it. I don't encourage that behavior. I want to live in a world where people are given credit, but I also don't want people to feel like, oh, I don't want to go use this open source thing because then I got to deal with attribution, and it's a bit of a headache. And especially if you want to do it right. Most people just kind of ignore the license and don't actually follow the rules. But technically, you're supposed to give attribution to every single piece of software you integrate and use. And so we care greatly about sharing this stuff. If anyone wants to, rip our code off, you're free to do so. Again, we would appreciate it if you give us a little bit of a thumbs up or whatever, or star or whatever it is, tweet, whatever helps us out. But it's not required at all. Like we want Ethereum to be better, and if that means that someone goes out and steals all our code and then makes a superior product and that makes Ethereum better, then I feel like we've been successful at that point. We also do all of our development in the open, so we have a Discord server that our dev team talks in, and it's a non-private channel. We do have a private channel in the Discord server, and it gets almost no traction. All of our dev work goes in the public channel. We discuss openly there. We discuss our designs. We discuss our code. Our PRs are all publicly visible. There's literally nothing about anything we do that's private, basically. And so yeah, if anyone wants to contribute or build on top of it or integrate similar features into your product, you want to see how we do it, feel free to take a look.
Yeah, that's great. I mean, that's as permissive as you can get, basically. Are Luminaria and Bouquet also open source?
Yep, Lunaria and Bouquet are both fully open source, also under the unlicensed, so you can go use them as like a template for some product you want to build. It's totally acceptable. We're currently working on getting them IPFS hosted. We normally IPFS host everything by default initially, but we kind of were lazy and it was slightly easier to host them just on GitHub pages, and so we're hosting on GitHub pages right now. We are in the process of getting those posted up to IPFS. And the reason this is important is because if you go to lunaria.dark.florist, you're trusting that whoever owns that domain name today, or on the day that you browse that website, is honest and legitimate. And that's a very dangerous thing. And this is part of why we built Interceptor, you shouldn't have to trust every website. That being said, there's another option here, which is to use IPFS. And so you'll notice that over in Uniswap, I'm browsing these two Uniswap pages are both IPFS hosted. And what this means is that I don't need to trust whoever owns or builds Uniswap today. I need to trust whoever built Uniswap at the time that I got this IPFS hash. And so with both Lunaria and Bouquet, we'll hopefully get them published on the IPFS soon. And then at that point, then you can just save a bookmark to the IPFS version, and then you don't have to trust us ever again. So the idea here is from a trust standpoint, and trust modeling, there's a big difference between trusting a person at one point in time versus trusting that person at all future points in time that you interact with them. And by using content hashing or IPFS, what this allows you to do is trust that whoever built the website at this particular point in time was trustworthy. You don't have to trust that whoever owns the website 5 years in the future is also trustworthy. And it's a really big difference. One of the reasons it's a big difference is because you can talk to somebody that you do trust. Like maybe you have a friend who's a nerd or whatever, and they do audits and security audits, and they tell you, yes, this website, I've done an audit of it, and it's good. The code is quality, and you trust your friend at that point. You can then copy that IPFS hash or bookmark the page, and you don't have to worry about asking your friend every single time you use the page, hey, is this page still legitimate? Are any hacks been introduced into this website since I talked to you, last time I used the website? That's not realistic. You can't realistically talk to your your tech buddy and get permission from him or her every single time you want to browse another web page. And so by using these IPFS hashes, you make the trust operation a one-time operation, and you can do a lot of due diligence. You can be very careful about making that one trust operation. You bookmark it, and you never have to worry about going back and doing that due diligence again, unless you want to, get the latest version of the website or whatever, like you want to get new features or something. And so Lunaria and Bouquet currently are not IPFS hosted, but it's one of our top priorities. We have someone working on that actively right now. And so hopefully, within a couple of weeks, it'll be on IPFS, and that will further reduce the need for trusting us on those. But yeah, for now, they are open source at least. You can just build and run them yourself if you're technically savvy. Or if you're, a little concerned, you could wait a couple of weeks. We'll get them on IPFS, and you can just bookmark those.
Yeah, that's really awesome, especially since you can just host it yourself. That trust vector of having to put your private key online in any way goes away, very quickly.
Yeah, and with Bouquet in particular, one thing I didn't mention is that we were very careful in Bouquet to not make any external requests anywhere else. So you'll notice that you have bouquet.dark.florist. I'm looking right now at the Bouquet website, and you can see this is the kernel debugging tools. We are only making requests to bouquet.dark.florist. If you're browsing this website via IPFS, and particularly if you're browsing it via localhost IPFS or a local build, you'll notice that it only makes requests to your local machine. It does not go anywhere else. And that's very important because it makes it very easy to audit. Like an auditor can come in, play around with this a little bit and see that, oh, they're not actually making any external requests. And in fact, if you look at the requests that are being made, these are just requests for images, JavaScript files, CSS, and HTML. There is no external JSON requests, no XRC requests, nothing like that. And so we intentionally designed this page, because it's asking for a private key, to be very, very easy to audit. And a professional auditor should be able to come in, take less than 15 minutes, and verify that this page is not doing anything sketchy, at least at the time they audit it. And with IPFS, we can get strong guarantees that it's not going to do anything sketchy ever because they audited it at that point in time. There are some underhanded things one could do to bypass an audit like a quick 15-minute gut check audit like that. But we also intentionally write the code to be a reproducible build. We don't obfuscate anything. We don't hide anything. Everything is written to be as easy to audit as possible. And one of the things we do in pursuit of that is we try to minimize our dependency set. So a lot of application developers just kind of go out and just like, oh, I'm just going to use whatever dependency solves my problem. We're very careful in what dependencies we use. We have exactly 4 dependencies here: ethers, preact, fun types, and a second preact one. And the reason for this is, again, for auditing purposes. I've done auditing work in the past, and one of our co-founders also did auditing work. Actually, I think a couple of our co-founders have done auditing work besides me. And one of the things that's really hard to audit is supply chain attacks, because people just include, third-party software in their stuff, and any of that third-party software can and has in the past been compromised. And so it's not just our deployment process that we try to make easy to audit and easy to secure, but we also try to make our build process as easy to audit as possible, because we know how hard and painful and time-consuming it is for someone, even someone who's very technically savvy, to go through and identify, is this a secure application? And so things like deterministic builds, things like easy to audit software, things like minimal dependency sets that are easy to kind of scan through and are well known. So, Preact is a very big name thing. Ethers is a big name. Fund types, not a huge name, but I mean, it's not unknown, and it's relatively small as well. All this is an effort to make it so this software is something that people can trust, even though we also go to great lengths to make it so they don't need to trust it. So building things like Interceptor makes so you don't need to trust these pieces of software. But even with that, we still also want to make it easy to validate and audit. And that includes Interceptor as well. We have the same policy for Interceptors, even though we're an extension. And because we're an extension, download times usually don't matter too much for people. Like they're willing to download a 40 megabyte extension, but they're not willing to download a 40 megabyte web page. Even though we could get away with having a bajillion dependencies, we very intentionally keep the Interceptor dependency set very, very small. And again, it's all for that security and privacy and things like that. And it's unfortunate because in this space, I've been in the space long enough and in security research long enough to know that 99.9% of people will not look into any of these things or even know what any of the stuff I just talked about means. But I feel like it's still very important to do, even though you can get away with not doing it, and everybody does. I don't think it's the right thing. Like, to me, doing the right thing here means, making your code easy to audit and making your code secure, making your code private. Sure, we can get away with it without doing any of that. Like, we could choose not to. But I think it's important that at least some people in the ecosystem try really hard to do those things, do the right thing. And at least in my opinion, we're trying to do the right thing here.
Yeah, I think that is definitely apparent from the intention behind how you build all of your tools. So super cool. My last question is on just kind of future plans. I see this as a very important security tool. So, blacklisting of known malicious addresses and just other general safety updates that could be used to make Ethereum a safer place to interact with. Are any of those type of things on your update list? And what other privacy and security based updates do you think are important coming down the line?
Yes, so the short answer is yes. We've got lots of plans for all sorts of things, including things you listed. Short term, the things we're focusing on is trying to cover the most common cases and build general solutions. So the swap part that you saw, where you can see that you're swapping one asset for another, we built that in a generalized way, so it doesn't just work with Uniswap. It works with any swapping tool that you're using. And so because of this, initially we're trying to cover broad strokes of things. We have limited development team, limited budget, and so we're just doing the best we can to cover as much as we can. As we cover more and more of the broad strokes, we'll start to narrow in on very specific things. And so, as an example, there are scams out there that we can automatically detect, like approving an EOA, very common scam. And we can automatically detect that for all versions of that scam. And so we generally prefer initially to do that sort of thing. Later on, we want to get more and more specific and more narrow on kind of the individual scams, for example. Like if there's one that's kind of rampaging through Ethereum, we want to catch that one specifically. So blacklists are, like you mentioned earlier, is one way to do that. The one hesitancy I have with blacklists is that because we care about security and privacy and censorship resistance and all these things, an updated blacklists, like maintaining an updated blacklist, is really hard because you need to have a really quick turnaround time, and which means you basically need to automatically push blacklist updates to users. And pushing blacklist updates to users requires one of two things. Either you've got some push mechanism that allows you to force something onto a user's environment, which from a security standpoint is very risky, because if we get compromised, then someone could push malicious data through that same channel. And so you have to be very careful on that front. On the flip side, if it's a pull basis, and so like maybe the user has a button in the Interceptor where they can fetch, then we need to follow the same privacy conscious pattern that we talked about earlier, where the user has to proactively do it, because we really don't want things in the background to automatically be going out and talking to the internet. We don't want the internet to know you're using Interceptor unless you tell the internet you're using Interceptor. Like it should be, no one should be able to even know that you're using it. And by pinging some blacklist to see if there's an update, even something as simple as that, is letting the world know that I'm using Interceptor. And that's, one more piece of information for your global fingerprint or your digital fingerprint. And so we have to figure out ways that we can achieve our goals without compromising user security. And so for now, what we do is we basically build things directly into the extension. So when we come up with new protections and whatnot, we build them right into the extension. And then next time a user updates the extension, they get all the latest protections. This isn't super ideal. And so maybe, we'll add that pull where the user can press a button and get the latest, updated blacklist and whatnot. But for now, that's our strategy. So yeah, so the TLDR of that is we're focusing on broad strokes protections first. And then after we kind of cover all those, helping users understand what they're doing. So part of protection is also not just telling them they're about to do something stupid. It's also just telling them what they're doing, like showing the user what they are actually doing. Because oftentimes some of the scammers use normal looking things to do bad stuff. And so by just helping the user see, oh, I'm doing a swap and Uniswap, but the deal is really bad. Like just telling them that, is a really powerful feature. And so the broad stroke stuff first, then we're going to start narrowing in. And as we start narrowing in, we're going to probably need to figure out ways to update quicker, because the more narrow you are with your protections, usually the shorter the time frame they matter. And so eventually we'll have to solve that problem. We haven't solved it yet, but yes, all of this is on our list. We have a giant list of features we want to add that all are kind of driving towards helping users understand what they're doing and helping protect users from malicious activities on the internet.
Yeah, that's fantastic. I guess I'll just open up the floor to you. So if there's anything else you want to say to the Ethereum community at large, feel free to talk about it now.
I don't think I have anything specific other than protect yourself out there. It's a very dangerous place. We see because of our bouquet, our tool for helping users recover assets, we see a lot of the people who have suffered the consequences of all the bad stuff, and so we see a lot of this. And we also, like I said, our founders have all been in this game for a while, and we've seen most of the things that happen, and it's really unfortunate. So be very careful out there. If not Interceptor, find some other tool that helps protect you. Be careful of what you're signing. Don't just blindly click things. Yeah, I guess I think my one takeaway for users is please be careful on the internet. It's a dangerous place.
Okay, yeah, awesome. So thank you everyone for watching this ecosystem project demo. I think we all can agree that this is a labor of love that is definitely going to help a lot of people be safer on the internet and safer interacting with Ethereum. So thank you, Micah, and thank you, Dark Florist.
Thank you very much.